So, we learned that because of the flow of charges, we are getting electric current. So, can the electric charges flow by themselves? No, the electric charges are not flowing by themselves. Something external is causing them to flow. So, have you ever wondered what is the reason behind or what is causing the electric charges to flow? So, in this topic, we are going to learn about what is the cause that is causing these charges to flow. So, before coming to that, in your houses, how you get water supply from the tank? Okay, you have a water tank. Okay, where is the water tank kept? It is always kept, mostly it will be kept in the terrace or in the top of the house. Why? Because see, suppose this is the tank and there is a tank below. From where, which tank to which tank will the water flow? Yeah, the water will flow from the higher tank to the lower tank. Why is this happening? Why the water is flowing from higher to lower? Because this point is a high pressure point and this is a low pressure point. Okay, so the water is flowing from the higher pressure point to lower pressure point. That is, there is a difference in pressure. When there is a difference in pressure, the flow takes place. Okay, that is what the water here is flowing from high pressure to low pressure point. Understood? Similar is the case in case of flow of charges. That is, in case of a metal wire or a conductor, the charges always flows from high electric pressure point to low electric pressure point. So you understand why the charges are flowing. The charges are flowing because of the difference in pressures. Okay. We can say that in a conducting metallic wire, electrons move only if there is a difference of electric pressure. Okay, so here the difference of electric pressure is known as what? Potential difference. Okay, potential difference. So what we understood? Charges are flowing in a conductor only if there is a potential difference. So what? So for the flow to happen, there should be a potential difference. In an electric circuit, this potential difference across a circuit is obtained through a medium of cell. That is, suppose this is an electric circuit. Okay, there is a bulb. Okay, connecting a cell. So for the electricity to pass, there should be potential difference. Okay, what if I am not giving a cell here? Is there a potential difference? No. To create a potential difference, I am connecting a cell. Now there is a potential difference and the charges will start to flow. As a result, electricity will be produced in that circuit. Understood? Okay. So, always remember, in case of a potential difference, the flow always happens from what? Higher to lower. This is very important. Okay. In the case of potential difference, the flow always happens from higher to lower. We observe the same case in case of water also. The water is flowing from higher potential to the lower potential. Similar is in the case of the electric charges. The electric charges will flow from higher potential to lower potential. Okay. Let's see the formula of potential difference. Okay, potential difference. Okay. So, the potential difference is defined as the work done per unit charge. Okay. So, the potential difference, here we are denoting by the letter capital V. equal to work done by charge, W by Q. Okay. Okay. So what you can tell that it is the work done per unit charge. Okay, work done per unit charge. What is the unit of potential difference? That is V, volt. It is, the SI unit is volt. Okay, volt. And what is the unit of work done? It is what? Joule. Joule. Okay, we denote it using J. Okay, and you know, obviously you know the unit of charge. It is what? Coulomb. Okay, coulomb. So how can you define 1 volt? 1 volt. How can you define? When 1 joule of work is done to carry a charge of 1 coulomb, then the potential difference is said to be what? Said to be 1 volt. Okay, please take down the notes while I am giving the class. Okay, so what you got? What is the potential difference? The potential difference, see, if suppose I am having a unit charge with me. If I want to move this unit charge from this position to this position, then the work done by me to carry this unit charge from here to here is known as what? Potential difference. Okay, so what is potential difference? Work done per unit charge. Okay. Okay, what is the instrument that is used to measure the potential difference? It is voltmeter. Okay, voltmeter is the voltmeter. Voltmeter is the instrument that is used to measure the potential difference across a circuit. And can you tell me how this voltmeter will be connected? This voltmeter will be always connected in parallel to the circuit. Okay. How will the voltmeter be connected? It will be connected in parallel to the circuit. And how is the ammeter connected? The ammeter is connected in series to the circuit. Okay. So what is series and parallel connection? See, in series connection, see, this is one bulb V1. Okay. This is the second bulb V2. Okay. Here, both the bulb are connected in a single line, same line. Suppose this is the wire. If I am connecting both the bulb in the single line or the single wire, then it is known as what? Series connection. Okay. In series connection, see, the point to be noted is that the current will be always same. That is, if suppose I is the current that is passing through the circuit, the current I will be passing through the bulb V1 as well as V2. Understood? See, I is passing. Okay. So the current in bulb V1 will be I and the current in bulb V2 will be I. That is, current is same in the series connection. But in case of parallel connection, what is the difference? See, we are connecting the bulb V1 and V2 in a parallel mode. That is what? See, this wire is divided into 2 parts. Okay, it is divided into 2 parts. And here it is again getting joined. Understood? The wire is getting divided into 2 parts and it is getting joined again at this point. Understood? Here what is happening with the current? The current I is flowing through the circuit. At this point, the current gets divided. Okay, the current gets divided. And see, the current, it is getting divided into I1 and I2. The current I1 is flowing through the bulb V2 and the current, okay, let's name this as V2 and this as V1. Okay. See, the current I1 is flowing through the bulb V1 and the current I2 is flowing through the bulb V2. And here again both the currents are getting added and it is flowing as I. Understood? So what is happening here? The current I is coming here. It is getting divided into I1 and I2. I1 is flowing through this pathway and I2 is flowing through this pathway. At this point, both the I1 and I2 combine to form I. So I is equal to I1 and I2. So in a parallel connection, the current will be different. That is, it gets divided. But in a series connection, the current will be equal. Okay, same in all the appliances. So we told that what is the difference between an ammeter and voltmeter? You might get this question for your exam. Okay. So the first point you can tell what? Ammeter. Okay. Okay, I'll write in this page. Okay. So what is the difference between ammeter and voltmeter? Ammeter is denoted by the symbol. Okay. Voltmeter is denoted by the symbol. Okay. Ammeter is used to measure what? Used to measure what? Electric current. And voltmeter is used to measure what? Used to measure what? Potential difference. Okay. And ammeter is always connected in what? Ammeter is connected in series. Okay. Connected in series to the circuit. Series. And voltmeter is connected what? Connected in parallel to the circuit. Parallel to the circuit. Okay. Understood? So, note down these 2 points. Okay. Now let's do a question related to potential difference. What is the question? How much work is done in moving a charge of 8 coulomb across 2 points having a potential difference of 3 volt? Okay. So what is given in the question? Charge is given. Okay. That is Q. Q is equal to 8 coulomb. Then what is given? Potential difference, that is V is given. V is given 3 volt. Okay. They are asking how much is the work done? How much is the work done? So we have to find out the work. Okay. So how much is the work done in moving a charge of 8 coulomb across 2 points? Okay, having a potential difference of 3 volt. So what is the formula? V is equal to W by Q. Okay, we have to find out W. That is W is equal to V into Q, which is equal to 3 into what? 8 is equal to 24. 24 what? What is the unit of work? Joules. Okay. So this is the answer. Okay, got it?